Welcome to another video in our series Commissioning of a variTRON system. My name is Manfred Schleicher and I work at JUMO as a technical trainer. In this video I will show you how to implement sequence control using a program controller for process technology. In particular, I will set up the control for a climate chamber. Using a generator, the user can then specify temperature profiles that are regulated in the chamber. However, sometimes the relative humidity must also be specified. I will show you all the necessary settings. Let's get started. You are now in the generator screen. You use the generator to specify set points as profiles and to control additional actuators during the profile sequence. Imagine that you are operating a chamber for treating samples. Sometimes you only need to specify a temperature profile, which is then regulated by a controller. However, you often also need to regulate to a defined humidity. At the moment, the chamber is not in operation and you can see the current temperature and humidity in the chamber here. This is the basic state of the generator. Depending on whether you are controlling only the temperature or also the relative humidity, you use different process steps. I now select the process step, with which I regulate the defined temperature and control a fan. This process step is called heating. I specify a time and a temperature and indicate whether I want to control the additional fan. I activate the process step. The temperature set point is specified. This is regulated by a controller. In this process step, the time only starts running when the actual value is within a band of ±2 Kelvin around the set point. The fan is activated. After the specified time has elapsed, the generator returns to its basic state. If I want to control a specific humidity in addition to the temperature, I use the heating and humidification process tab. I now select this. I specify the respective set points. In this process step, I do not have the option of controlling the fan. I activate the process step. The tolerance band is not used in this process step. The section time starts immediately. A second control channel controls the required humidity set point. After the time has elapsed, the generator switches back to the basic state. The process steps are normally executed one after the other, which is done using a program. I created a program before, which I'm now starting. In the first section, the temperature inside the chamber is increased in a ramp to 50 degrees. The heating process step is used for this. The temperature is then increased in a ramp to 150 degrees Celsius, and the humidity is also controlled to 70%. This is the second section, where the heating and humidification process step is used. Towards the end, in section 3, the temperature is regulated to 150 degrees Celsius and the humidity to 70%. This is also done using the heating and humidification process step. After the program has been processed, the generator returns to its basic state. You can edit the programs in a web application. You can access it in the CPU. It is called JUMO variTRON Program Editor. Here you can edit the existing program, for example, I will show you this in more detail on the end of this video. Now I'll show you how to add the generator function shown to the project from the last webinar. The program generator I showed you is the one for the process technology. I need an option for this, so I'll check in the web cockpit to see if it's enabled. Here I can see that the option is available in the system. First, I configure the settings for the control loops and smartware setup. I measure the temperature with a PD100 and 3-wire circuit. A continuous controller is used, and the actuator is controlled via a 4 to 20 mA signal. The humidity is available as a 4 to 20 mA signal. The controller also operates continuously, and the humidifier is controlled by a 4 to 20 mA signal. The RTD temperature probe is connected to analog input 2 of the controller module. I set up the analog input for the RTD temperature probe. The humidity sensor is connected to analog input 3 of the controller module. It provides 4 to 20 mA, which corresponds to a relative humidity of 0 to 100%. I make the settings for analog input 3. I use the second control channel for temperature control. I specify that the channel operates as a continuous controller and name it. I extend the set point limit to 0 to 200 degrees Celsius. For auto-tuning, I specify the type of controller output. This is continuous. I make almost the same settings for the humidity controller. This is control channel 3. I will control the actuator for heating and humidification via analog outputs 1 and 2 of the analog output module. I will have to link the analog outputs to the controller module later in codesys. However, I already have to take care of the output type and scaling here. The actuator for heating will later be controlled via a 4 to 20 mA signal. 0 to 100% controller output corresponds to 4 to 20 mA, so I can leave the factory scaling as it is. Analog output 2 will later control the humidification unit. I make the settings in the same way as for analog output 1. I now transfer the changes of my configuration to the system. After the system has restarted, I switch to the visualization. I am in channel 2, which is for temperature control. I will now set a typical set point and start auto-tuning. But first I have to log in. I set the set point and start auto-tuning. I do the same for channel 3, which is for humidity control. I wait for the auto-tuning to finish for both channels. The humidity controller has completed auto-tuning, as has the temperature controller. To transfer the control parameters to the configuration file, I load the configuration back into the file. This setting ensures that the configuration of the input and output modules is transferred. The control parameters in the configuration are now also updated. Now I need to show you a few general settings. You can use 4 process technology units in your system. This means that you could operate 4 of the chambers shown independently of each other. You can then define system types with different options. However, this is certainly too much for beginners and is only relevant if you want to use the same configuration for different system types. One plan type is available, and that is sufficient for most applications. You can also see here that the time is displayed in a specific format and an icon is shown. The analog values are also displayed with an icon and are shown with a specific number of decimal places. In some windows, a text description is also available for the analog values. You need to set how the display should look. I'll show you how. I am in JUMO Smartware Setup variTRON and here in the configuration section. In all menus beginning with PT, you can configure your generator settings. I will start in the configuration section. A system type named Standard is available by default, and you can find it here. There are 4 program generators, so to speak, and this system type is assigned to the first program generator, referred to here as PT units. You can see the setting under System Assignment. Now you can configure the general settings for the time, temperature, humidity and ventilation. I do this under Inputs Outputs. Under States, you can define the description used to display the status of digital signals. If you are using English as the device language, the default text is on and off. You can configure the time settings under section Time. This includes the icon to be displayed, the time format, and the text for the set point and actual value. Under analog values, I specify how the temperature and humidity are to be displayed in the generator image. Analog value 1 is the temperature, and the factory settings are suitable here. Analog value 2 is the humidity, and I need a different icon here. I need a different unit. I need to modify the description for the set point. And I need a different description for the actual value. The actual values and set points should be displayed without decimal places. Analog value 3 is not used in my application, so I am not concerned with its settings. The settings for the digital values are made here. In my application, there is only one digital signal, namely that for the fan. The fan is digital signal 1, and I select a suitable icon for this. In the windows in which the digital value is specified as the set point, a name appears for the set point. This should be recirculation. There is no actual value for the fan because there is no feedback signal. I delete the factory set name for the actual value. In my example, I am working with two different process steps that offer different options. In the heating process step, I can define the temperature, which is analog value 1, and I can specify the status for the fan, which is digital value 1. In the heating and humidification process step, I can also specify the temperature, but I can also specify a humidity set point, which is analog value 2. The fan cannot be controlled in this process step. You must define the properties of the process steps, and I will show you how to do this now. I am now in PT configuration process steps, where I delete all the factory set process steps except for the last one, which I cannot remove. I now adapt process step 1 to my process step heating. I call it heating. I select an icon for this process step. Now I define which parameters are used in this process step, how they are displayed, and how the set point is entered. Section time actual value is the elapsed time for the process step. This is displayed by default, which makes sense. Section time set point indicates that a time specification is possible. The time range to be set is not restricted. Under analog actual values, I set the analog values from which the actual values are to be displayed. I only need the actual value of the temperature, and this is analog value 1. Under analog set points, I specify which set points are to be used. Here too, I only want to specify the set point for the temperature. The set point should be specified in a ramp shape, and a set point specification from 0 to 200 degrees should be possible. Under default set point, I have the option of defining a set point that is suggested when the program is created. I would like to work with a tolerance band for the temperature. This means that the program stops if the actual value is not within a band around the set point. If the actual value returns to the tolerance band, the program should continue. I define the tolerance band here. I activate the first tolerance band and specify that I want to use it to monitor the first analog value. The tolerance band consists of a range below the set point and above the set point. I specify that the respective width can be set to 0 to 5 Kelvin during program setup. While the actual value is outside the tolerance band, the program is paused and not cancelled. This is set here. During program creation, 2 Kelvin should be offered for the lower and upper tolerance band range. In this process step, it should be possible to define the status of the fan, and during program creation, the fan should be offered as activated. I do this under digital set points. I do not have a feedback signal from the fan that I could display here. Therefore, under digital actual values, I specify that I do not want to use the first digital actual value. Now I create the process step heating and humidification. I name the process step and assign an icon. I want to display the actual value for the temperature and humidity. I also need the set points for both variables. The temperature profile is to be specified as a ramp. The maximum input value is 200 degrees Celsius. I activate the set point for humidity. The humidity profile should be specified as steps. The status of the fan should not be displayed. And the set point of the fan should not be used either. This defines this process step as well. When creating the program later, you can make individual settings for each program. These include, for example, whether a program always starts at the start of the program or at the actual value, whether a program continues or is interrupted after a power failure, whether a program should start at a set time, or whether parts of the program should be repeated. Everything that is to be adjustable is defined under process step init. The user should later be able to specify whether a program starts at the start of the program or whether the program is started where the program set point corresponds to the actual value of the temperature. To do this, the program behavior's light switch must be activated and the user must be able to select whether start at actual value refers to the temperature or the humidity. I deselect everything else. During program creation, it should be suggested that the start is at the actual value and that this refers to analog value 1. This means to the temperature. This is the display of my system in the basic state. Next, I will show you how to display the actual values for temperature and humidity in the basic state. And I would also like to be able to access the generator screen by pressing the Home button. By default, a batch log is created for each program sequence. However, I will disable this for now. I define the behavior on the basic state here. Under visibility, I specify that actual value 1 and 2 are displayed. And here you specify that pressing the Home button takes you to the generator screen. And now I'll disable batch logging. By default, batch application 1 creates a batch log for each program run of generator 1. I disable this. The program generators are implemented in the PLC, and in codices I have to ensure that the generator setpoints are made available via network variables. These network variables are in turn specified as setpoints for the controllers. Here it is advantageous for me to make the network variables available via the external setpoint function, and that is what I'm doing now. At the beginning I specify that the result of setpoint function 2 should be used as the setpoint for controller 2. Accordingly, I select the result of setpoint function 3 for the setpoint of controller 3. Now I select the variable in setpoint function 2 that I will later write from codices. I have defined that the result of setpoint function 2 is to be used as the setpoint for controller 2. The result of the setpoint function is the source defined under external setpoint 1 by default. Here I specify the network variable that I will later write in codices with the first analog setpoint. I proceed in the same way for controller 3 and setpoint function 3. Now I transfer my configuration to the system. Next, I check the display of the basic state and the two process steps. Here you can see how the basic state is displayed. You can see the two icons for temperature and humidity. The two actual values are still displayed as 0 because the links in codices have not yet been implemented. The setpoints are not displayed in the basic state, which is how it should be. Now I activate the heating process step. Here the time and temperature are displayed with the actual and setpoint values, as well as the setpoint for the fan. I define a time and the temperature setpoint. As suggested, the fan should be switched on. I activate the process step. Based on my settings, the tolerance band is set to ±2 Kelvin. The control deviation is 150, so the tolerance band signal is active and the generator stops. I stop the execution of the process step. Now I prepare the heating and humidification process step for start. You can see that the fan is not shown in the process step, but the humidity is shown with the actual and setpoint values. I specify a time. A temperature setpoint, a humidity setpoint, and I start the process step. Since there is no monitoring for the tolerance band here, the generator is not stopped. The generator is working, and in principle, the process steps are also functioning. However, the set points of the generator available in codices are not yet linked to the control channels. In addition, the actual values of the controllers are not yet available to the generator and therefore cannot be displayed in the generator image. I will now link the actual and set point values in codices. But I still have one thing to do. You may remember that we want to operate the two actuators for heating and humidification with the outputs of the analog output module. We need to link these outputs with the controller module, specifically to the controller outputs of channels 2 and 3. These are the signals for heating and humidification. I'll show you how to do this in codices. Now I map the outputs of the controller. I go to controller 2 to the inputs, and here I have the output level of controller 2 and I map it. I map the output level of the controller 3 accordingly. This is the output level for the humidifier. I will assign both output levels to analog outputs 1 and 2 of the analog output module in the main program. But first I have to map the two analog outputs. I map analog output 1 for the heating. I map output 2 for the humidifier accordingly. I had previously set both outputs so that they output 4 to 20 mA at a numerical value of 0 to 100. In the main program, I now assign the two controller outputs to the two analog outputs. In the main program, I want to create a separation from my previous program, so I start here with // and everything that follows in the program line is a comment and will not be processed. And here come the assignment. For analog output 1 of the analog output module, I assign the output of controller channel 2. And for analog output 2 of the analog output module, I assign the output of controller channel 3 accordingly. I now start linking the generator signals. I move in the system bus I/O mapping from the controller and go to the network variable that I specified at the set point for the temperature controller via the external setpoint specification. Here is the variable that I use as the setpoint for the second controller channel. And in the mapping, I can directly specify setpoint 1 from the generator. The variables for the generator are located in a global variable list. So I call up the first setpoint, for example. This is a signal from generator 1. The setpoint is an output signal. It is an analog value, namely the setpoint of analog value 1. I proceed in the same way for the setpoint of analog channel 3. Here I map the network variable that I connected to control channel 3 as the setpoint. The generator variable is almost the same, except that it is analog value 2. Now I have to provide the generator with the actual values for the temperature and humidity. I move to the network variable that reads the actual value of controller channel 2 into the PLC. The actual temperature value is available here, and so I connect it to the generator as actual value signal 1. I use the signal in generator 1. From the generator's point of view, this is an input signal. It is an analog value, namely analog value 1, and I only write the numerical value of the input variable. I proceed in a similar manner with the actual humidity value. I move to the actual value of channel 3. The actual humidity value is available via this network variable. This is analog value 2 for generator 1. Digital value 1 is the status of the fan, which I now assign to relay 1 of the relay module. I go to System Bus I/O mapping for the relay module. I use this network variable to control the first relay and enter the digital value 1 of the generator as the source. And that's how I completed my codesys extension. To check the program for errors, I generate the program code. The program is error-free. I transfer the program to the CPU and call up the web visualization. In the basic state, I now see the actual values for temperature and humidity. As an example, I choose the process step heating and humidification. I activate the process step. You can see how the actual values move towards the set points. And in the controller visualization, you can see that the set points of the generators are used accordingly. In codesys, I now disconnect and close the application. In the configuration program, I apply the changes of the codesys session. I return to the visualization and interrupt the execution of the process step. Now I create a program, and for this I start the JUMO variTRON program editor. I log in with the factory settings master 9200. Demo programs are available here by default, and I delete them. Now I create a program on program location 1. I name the program. I select an icon for this program. The options in program initialization I had previously defined in the configuration program. It is suggested that the program should start at the actual value, and that is how it should be. Start at actual value refers to analog value 1. This is the temperature, and that is also correct. I create the first program section. In this section I want to heat up the system, so I use the heating process step. I specify a time, a set point of 0 degrees Celsius, and I accept the suggested 2 Kelvin for the upper and lower tolerance bands. The ventilation should be active. in the second section I need to heat and humidify. Therefore, I select the Heating and Humidification Process tab. Here, I also define a time and a temperature set point for the start of this section. Section 2 should start with a temperature set point of 50. This is also the temperature set point at the end of Section 1. This means that in Section 1, the set point rises from 0 to 50 degrees in a ramp shape over the section time. The set point for humidity in this section is 70%. We continue with the third section. Humidification and heating are also required here. I define the section time and the set points for temperature and humidity. In this section, the temperature is regulated to 150 degrees Celsius and the humidity to 70% over 1 minute. I save the changes and switch to the visualization. You need to log in here. Then you can start the program. I introduced the program at the beginning of the video. If you like, you can watch it again there. To ensure that the program is also transferred to my configuration file, I will now transfer the configuration from my system again. And here's where my program is saved. Finally, I save my project and my extension is complete.